Alright everybody, welcome back. So in the last episode we managed to enable class definitions. The classes right now, let's look in here, like the actual class looks like this. It just has a name. The methods are not enabled yet. They are enabled in the statement, so they're also like enabled in the parsing, but we don't really do anything with them yet. So what we can do now is make a class like that, and we can also turn it into a string, so we can print it. But so we can define classes, but we cannot create instances yet, and that's what we're going to start by looking at in this video. Okay, so the way we're going to instantiate a class is like this, kind of like Python. So let's try this example that he has. So now we have a class, we can print it. We can also try to call it, but that will yield an error that says class is not callable. So it's because I really hate this formatting, but we end up here in on this line, because when we try to pass a call, it looks at the type of the call, callable, and right now we only support that this, actually we have a value called callable, which is going to be a little bit confusing now. And probably this should really be called a function instead, but let's not worry about that right now. So what we need to do is to add another branch of this match statement. So we will add this one. So we have a class right now just as a name, and what we need to do is to create an instance, and this whole thing always returns a literal value. So hold on, these are actually expressions, and wait, sorry, I'm confusing myself a little bit. So we have a call, looks at the callee, which is a value. So it is a literal value, and then it matches on that, so it can indeed be a class. So we need to create a new value from this thing. So that means we need to add a new, let's go all the way to the top, we need to add a new literal value. So how about this? Now we're just gonna try this. Let's call it class name string. And right now that would be it. Like later we probably want fields, which again, let's make it like this kind of thing. Yeah, so those are fields that just live on the instance. Probably we don't want fields up here then, so let me remove that. Well, let me add it again, and let me say it could also be static fields. Oh, actually, let's say it could also add static fields, because I think if we do add static fields, we want it to be in a different, like we don't want it to be under methods, we want it to be under fields. Anyway, so we could have fields And I wonder if we I wonder how we're going to handle methods. So, but let's go back to this line. And right now we will just create right, that's what I called it, right? Yes, an instance where the class name is a clone of the name. So now if we run this, it doesn't compile because now we need to add new cases to all of these, like the toString and so on. So I'm just going to do that. So now that we have all those added, let's try to run this example again. Make a Bagel class. And then we can try to make a Bagel instance. So now it does do something. But like we can assign to it, for example. But we cannot really do anything with this thing. The only thing we can do is print it and it will say like instance of Bagel. So let's keep moving. So one thing that I forgot is that here we should really check on the number of arguments. So we should say if arguments length is not equal to 0, then we instead return an error, and we will say well, so right now we don't really have constructors. So for now we will say can only call the constructor with 0 arguments. Now obviously it would be nice to change this at some point. But now if we do like class Bagel, and then we do Bagel 1, 2, 3, then it will yield an error. Good. And now that I'm reading here, so in his definition of the instance, it actually has a reference to the class. And that might that could be quite nice, because that makes it easier to access the methods, I think. So how about we just do this, and it's a literal value, and then we go to this line, which is like 488, and now the class should be the name, the callee, right? Or whatever. No, it should be the callable cloned. So let's try that. It did not work. Because now I have this. So we need the class.name instead. And instance of class.name. C. Right. And now the problem is that this thing has to be boxed. And then We need like box new, like that. Now should be working. But it doesn't work. Okay, this is a little bit annoying. The reason is basically like this is like a generic value of the enum, but we want the specific one. Can we do this? Is that a thing? No, it doesn't like that. Okay, I just googled it a little bit and I don't see any nice way to do it. So I guess we have to do like this. Missing some delimiter. Right. Okay, let me just fix this. Okay, so actually I need two dereferences because one is for this reference and the other is for the boxed value. So actually I'm going to like make a quick macro that we call that we will call class name, and it should simply take let's say the class, which is an expression, I think, and then it will do this. Yes. Although maybe we need to wrap it like that instead. And that one needs that, because now we can just write class name of this class, and that should work. And now we can do the same here. Class name, the class. And that did not work. Right, and it's because down here we only want the reference. Okay. And right here we don't need the name. Okay, anyway, let me fix these annoying compiler errors and then we will get back to the interesting part. So let's check if it works now. And let's make an instance. And let's print it. And it works fine. So Let's have a look at the book again. So we'll start by adding properties, and it's basically similar to JavaScript and Python, and we like access and modify properties like this, and an expression followed by a dot and an identifier reads the property with that name from the object the expression evaluates to. That dot has the same precedence as the parentheses in a function call. So we slot it into the grammar by replacing call rule with this thing. So that means we need to go into the parser. We need to have a look at a statement, I guess. Well, let me just check. So we have an expression statement. Let's have a look at that. And it's an expression assignment. And then we have this pipe thing. Kind of forget where the call is passed. And equality, comparison, term, factor. Okay, so here we have the call. And now we're changing the call, so it's a primary expression. It's a parentheses, and well, rather it's a parentheses and list of arguments. Oh, it's a dot. After a primary expression, we'll have a series of any mixture of parentheses called and dotted property access. So basically, we want to say, let me just check this match token, because I think it advances, right? Now it only advances if you get the type you expect. So we can say, okay, if it's not, and it's instead, I guess we call it a period, then we have a to do. Otherwise we go back and break like we did before. And let me check the scanner and see that we have this period. We don't. What is it called? It's just called a dot. So if we have a dot, then we do something. But before we do that, let's add the new expression type. So enum expression, and it's gonna be a get, and it should have like the object you're getting from and the name of what you're getting. So we can call it object, sure. It has to be boxed. And then we have name, which is a token. Great. And now we go into the parser just to get that done. So we have the same kind of thing here. So if we match a left parenthesis, we call the finish call. If we match a dot, then we do something else. So let's get the name, and we will consume a token, and then we'll say expected token after dot accessor, something like that. And then we will write that the expression is now a It's a get expression where the object is the previous expression and the name is the name. So I think that should be it. Because we have it inside this loop, then we can have multiple things, like access steps, or I don't know what to call it. So we can have something like this. We have an object, then we get the property, and then we get another property, and then we get a third property, and we can also call that one, because this object will be the first thing that's passed. Then we go into the loop, we see there's a dot, we will consume the next token, and we will turn that into a get expression. So later, I think we probably want to turn this into a method call, but we will wait with that. But then we go back into the loop and we see that there's another dot after we consume property. We see this dot right there. Then we consume property 2. We add, we change the expression again. Then we go back to the loop. We see the next dot. We consume this this property, and right now, after all of those steps, we have a get expression where the object is this first part, the name is that part, and let me delete this. Then we go back into the loop and we saw the left parentheses that was there, and then we finish the call. So we will finally get a call type that has a callee that is like this get expression that we have constructed, and the arguments is in this case it's just an empty vector and so on. So that's basically how this loop allows us to have multiple property accesses and also call parentheses. Okay. The outer while loop there corresponds to the star and the grammar rule. We zip along the tokens, building up a chain of calls and gets as we find parentheses and dots, like so. Yes, exactly. So if we have this egg.scramble3 with cheddar, then we first pass the egg, which is this primary thing. Then we go into the loop and we see that there's a dot. So then we pass the name, which will be scramble. Then we go out and we make a get expression out of that. So then we make a, basically like if you look at this dot, the egg and scramble, those will be turned into a get. Then we go back into the loop, we see a parentheses. So we go into the call, it will pick the argument 3, and then it will take the get expression that we made here and turn that into a call. The get expression and the arguments, I'll turn that into a call. Then we'll go back out, start the loop over, we see another dot. We get the name, so it will see that the name is with, and it will take the call and the with and turn that into a get expression, and so on. So now we need to resolve that, which always fills me with fear. So we have a new expression here, and it's an object and a name. What do we need to do with that? We just want to resolve the object, I guess. the name is a token, so it's like not, it's just a string basically, so it doesn't need to be resolved. During resolution, we recurse only into the expression left of that. The actual property access happens in the interpreter, sure. So let's go to the interpreter and wait, what is this? This is, for us, it will not be in the interpreter, it will actually be in here, where we have to change this evaluate method. So let's find a good spot. Where's the grouping? Not there. Here. So let's add it up here. Get. Am I in the right function? It's a bit hard to navigate this. Which probably means we need to restructure it. Okay. Anyway, so we have a get, has an object, has a name, and we need to evaluate that. So basically, we need to get the value of the object. So we evaluate that, evaluate, and it needs the environment. It needs the locals. And it can go wrong, so we unwrap the error value. Then we need to, so now object value should be a logs instance. So we can basically say if let do we need that logs instance, and what does a logs instance have? Again, right now, what does it have? It just has a class. And let's see. So what does he do? He evaluates the object, sure. And if it is an instance, then we call this get method. But we don't have the get method yet, so let's add the fields now. Then we'll say class and fields equal object value. Then we do something. Otherwise, we return an error that says cannot access a property on type. And then we want the object value to type. And that's it. Now, what do we do here? So if we actually have a correct type, then we need to look in the field. So I deliberately chose the fields here to be a vector of strings and literal values. It could also be a hash map, but I just kind of want to show that you could also just do it this way, and it's probably fine because you will never have like tens of thousands of fields. But you can, that's an optimization you can always make. So now we need to look through the fields, and let's say for can you do this for name value in fields? And then if the name is equal to So let's call it field name. And if the field name is equal to the name that we want to find, then we can return OK of the value. And if we don't find anything, then maybe we just say that the field value is nil. Let's try that. And check the compiler. So, what did I do wrong there? How? It's not, it's because we have to get an identifier. Okay, so now we have some annoying compiler mistakes. Let me fix those. And now, of course, we have to remember that when we create the instance, we have to initialize the fields. So that will just be an empty vector. And then over here, the field name is a string, but the name is a token. So we actually have to look at the string value of that. Okay. Right, we actually need to return it in here. That was my bad. And I will see you after these compiler errors. Right, so one thing we forgot is that we need the IDs for everything. ID, object is irrelevant, name is irrelevant. So it will just be the ID. And then in the parser, when we construct it, we also have to say get ID. And all right, and we're back with basically a clean build now. So let's try a little bit. We can make an instance and we can access a field, and it can be anything like that. Now, I don't think we can say like assign to it. Yeah, so we don't support that yet, but we can access fields. And I think that's it for this video because it's already quite long. But in the next video we will let me see. Yeah, so here he has this hash map and he looks up the value in that, and we just have this vector because why not? And here an interesting edge case is we need to handle is what happens if the instance doesn't have a property with the given name. We could silently return a dummy value. Yeah, so probably actually I kind of agree with that. If we don't find anything, we will return an error. No field named on this instance. So now we return an error instead. So if we do the same thing, and then we say test, or like let's say we actually print it, then it will yield an error. And that exact case I'm going to make a test case for. Access non-existing field. And here's the test. So let's say that's it for this video, and I'll see you on the next one.